Top chamber right around 800 degrees. Lower chamber about 900 degrees. Zone 2 has been plugged up, so we only have gas coming into the grate in zone 1.
99, 170,
Good gasification on the pile. And we'll see what happens. Top of the combustion chamber, running on green waste. $37.5 on the ID pan, $16.50 in the top of the box. See an air leak in the ceramics there. Top of the arch. See how full the top of the box is in combustion gases. Like this. November 24th, 2008. Test cell. We're running green waste in through the grinder. The screen on top. Screw conveyor. Material running on the screen. November 24th, material running in the hammer mill, all equipment running. Material coming to the bottom of the screen, even though the screen is covered up to keep all volume going to the hammer mill. Some of it's still getting through. Up the conveyor belt, the material going to the hammer mill. This is the takeaway screw auger from the hammer mill. Speed of rotation. You see it's taking material in from the hammer mill, bringing it down. The ambient noise level is the hammer mill operating without any shielding. Materials coming across. Up this screw conveyor. The belts going across and being dumped out the side. That's the vibratory screen working. The front end of the combustion test cell. Sending fuel feed into the rotary airlock, to the fuel chute, primary drive for fuel into the unit. flue gas recirculation coming around to the grate along with fresh air flowing to the bottom of the grate. Expanded capacity heat exchanger. Heat exchanger exhaust to the roof. Back into the combustion test cell, it shows the ceramic enclosed chamber leading the test cell, coming around the emissions control testing section, and the heat exchanger. Station right there is where we can draw exhaust samples out during runs of specific material in the test cell to evaluate the emissions that are generated and how they are destroyed in the process. This fuel box I'm looking up at is a 40-minute fuel supply for the Kitty Hawk combustor, along with the spray tank scrubber for the combustion test cell, which is located directly inside it. This is the combustor for Kitty Hawk with 3 15 million BTU an hour combustion cells. It's been skinned with steel. There are 3 cells inside where we're installing ceramics. You can see where the arches have been installed. There's the back door. Arches have been installed. On this side, the roof arches have not been installed. Center cell. Arches have been installed. And the roof arches have been installed as well. That gap is where the front wall will be sprayed in place. These tubes are the fuel feed chutes. The chamber is about 5 meters. This is the third chamber. Once again, does not have the top arches in place yet. You can see the roof of the building. Sidewall to be sprayed in place here. Here's the back door. This is the gap connecting the 2 chambers. This is another view of the combustor from the turbine deck to the 4 feed chutes and the screw auger assembly that will be supplying fuel to them. Top of the combustor, coming around with the exhaust, which comes around and then drops down to a Nebraska D-style steam boiler that we have harvested and recovered and modified to be a heat recovery steam boiler by removing the gas burner and replacing it with an entrance to accept the exhaust of our biomass combustion system. This steam valve assembly brings the steam from the boiler over to the steam turbine. In the distance is one of the dust collectors and one of the spray scrubbers, which we'll get to shortly. This is the steam turbine generator set. It is a 5 megawatt unit that has been dialed back to 2.8 megawatts. Operates at 450 psi steam at 750 degrees. It was commissioned in 1943 in the USS Rudderell, a destroyer escort U.S. Navy. It has been overhauled and completely rebuilt and is good for another 80 years. That is the top exhaust chamber of the combustion cell. As I pan around, get a shot of the walking deck that goes along top of the feed chutes for the combustion unit. This is a shot of the bottom of the fuel storage box. 10 stroking cylinders of 50,000 pounds each, hydraulically driven, 350-ton storage box. You can see up this side that the bottom of the box on each stroking arm is a series of flights. They're basically triangular in shape. They push under the fuel and then bulldoze it out from the bottom. In the top of the unit there is a trolley assembly that allows you to drop fuel into the box just about anywhere you want. And in a minute we'll crawl up there and take a shot of that too. This is a shot from the wet electrostatic spray precipitator catwalk back at the steam turbine generator set. That is the exhaust chamber in the distance from the combustion unit dropping down to the green box, which is our boiler. Exhaust then goes through this box next to me, which is our catalytic converter, through this unit, which is a economizer, where we take boiler feed water, which is at room temperature, and we warm it up to about 700 degrees before it goes to the boiler to detach the steam. The result is that the exhaust is cooled about 300 degrees, and it goes through this exhaust duct, through 3 dust collectors, around through a duct to this induction fan. And it blows it in to a spray scrubber, which then brings it across underneath the decking into our wet electrostatic spray precipitator. Which is basically an ionic freeze air cleaner on steroids. The inside of the precipitator, if I can get this, has a plate, electrodes, and a honeycomb where it collects dust, much like your TV screen does when you're running on TV. Spray water on it, it's self-cleaning. It also acts as a 2-stage condenser and will harvest water out of our system as we go forward. This is a shot of our motor control center, which is currently running right now as we operate our grinding and fuel transfer equipment. In the motor control center, we have all of the drives that control every motor and fan in the facility. That digital noise you hear in the background is why they're all located in a box away from the employees. One motor control center per combustion system. This is the top of the fuel box.